Now that we know what a continental margin is, in this video we're going to look at the two types, our active continental margins and our passive continental margins. Continental margins are where our continents are transitioning into oceanic crust. So the continental margins are typically found under our water, but they're still continents. They're felsic rocks made out of granite instead of mafic rocks made out of basalt. But we're going to have two types of continental margins that are going to differ based on whether they're tectonically active or not. So we have active continental margins, where we have active plate tectonics going on. And then we also have passive continental margins. And this is where we're going to start for this video. So these passive continental margins aren't really associated with plate boundaries. Instead, it's going to be on top of a plate that area has not moved for a really long period of time. And because these passive continental margins don't have active plate tectonics, they don't have active volcanism, and they have very few earthquakes. And the few ones they have, again, are not related to plate boundaries. But looking at our globe, we find most of these passive continental margins around our Atlantic Ocean. This figure is showing us what a passive continental margin off the coast of the United States looks like. On the east coast of the U.S., where we live, is along the Atlantic Ocean. Here we don't have active plate tectonics going on, which I'm incredibly thankful about. Along our east coast, we don't have to worry about volcanoes or massive earthquakes because the crust is just passive, it's sitting there. But our passive continental margin, we're going to see that we're going to transition from that really thick continental crust to that thinner, denser oceanic crust. But as we transition between these two majorly different types of rocks, we're going to see that the continental margin is going to have three major areas on it. We're going to have a relatively flat, gently sloping shelf. If you've ever been to the beach and you've been able to walk pretty far off the coast in the water, you're walking along the continental shelf. You're still walking on top of a continent, it just happens to be underwater. But if we could walk a couple miles off of our continental shelf, we'll hit our continental slope, where we're going to have a really steep slope that will end in our continental rise, where we're going to get things like deep sea fans coming out of our submarine canyons. But we're going to go over each of these in just a little bit more detail. We're going to look at each individual feature of our passive continental margin, starting off by the actual continent and then working our way out farther and farther off the coast into deeper ocean waters. But starting with our continental shelf. Again, this is just a submerged area of our continent. It's under seawater, but because it's that thick continental rock, it is still a continent. And the width of this continental shelf is going to vary depending on where we are. Along the northeastern U.S. coast, it's relatively narrow, but by the time we get down to Florida, if you look at this image, the continental shelf of Florida is actually about 3 times as wide as the Florida above the water that we know of. So the width of our continental shelf, it really just depends on the size and shape of the continental plate. But overall, regardless of where we are or how wide it is, all of our continental shelves are very gently sloping. They're not quite flat, but they're pretty close to it. And they're relatively featureless, so they don't have a lot of ups and downs on them. They're just very flat. But geologically, these continental shelves are incredibly important because this is where all of our oil is for our transportation, and it also has some really important mineral and rock deposits that we use for things like our electronics. But once we start transitioning from our continental shelf, we will soon hit our continental slope. And this is going to be the exact edge of our continental shelf. Here, the slope is going to get really, really steep as it transitions from that thick, buoyant crust of continent and that really thin, dense oceanic crust. But at the bottom of our continental slope, we're going to get into a slightly more gentle gradient here of our continental rise. It's not as flat and as gentle as our shelf is, but it's nowhere near as steep as our slope. And here at our continental rise, because the gradient is slowly starting to flatten back out, sediment is going to accumulate here. So all of the sediment that's moved down the shelf and the slope is going to end up being deposited in our continental rise. And a lot of the time this is going to end up in what's called a deep sea fan. This is where we have sediment coming from our continents, especially from our rivers that are coming from the continents. And as those rivers discharge into the oceans, they're not just releasing their water, but all of the sediment as well. So that sediment is going to flow down this really steep slope and end up in these deep sea fans along our continental rises. So all of this really sediment-heavy water, this is called a turbidity current. And this turbidity, it just means it's water with a whole bunch of sediment inside of it. So when we have water full of sediment, just like it did in a stream, it's going to start eroding the sides. So when we have areas where we have lots of sediment in our water, again, especially where we have rivers discharging into our oceans, we can have submarine canyons develop. And just like our Grand Canyon, these are going to be really deep, really steep-sided valleys that are cut into the continental slope, where all of that water and sediment is being moved downhill due to gravity. Our active continental margins, though, are totally different from our passive. Passive, it's accumulating sediment, it's just sitting there because it's not tectonically active. Our active continental margins, though, as the name suggests, are tectonically active. So in these continental margins that are active, we generally see subduction zones occurring. We're going to have lithosphere that's being subducted underneath the edge of a continent, and this is going to create one of those deep sea or deep ocean trenches that we talked about with our plate tectonics chapter. And we saw that passive margins surround the Atlantic Ocean, but our active continental margins surround our Pacific Ocean. Remember that ring of fire that we discussed where there was lots of subduction around the Pacific? That's why our Pacific Ocean is surrounded by active continental margins. We just have tons of subduction and volcanism going on here. But as we have subduction, the plate that is being subducted or pushed back into the earth is slowly going to start deforming some of the sediment and rock from the overlying region and form what's called an accretionary wedge. An accretionary wedge is just a triangular shape area where sediment has been scraped off of the other plate. So this map is just showing us where those active continental margins are. And remember, active continental margins happen where we have subduction, where we have an oceanic plate subducting underneath a continental or another oceanic plate. So just like we saw the ring of fire when we were talking about volcanoes and again with earthquakes, we see that our active continental margins are found on the exact same locations on our planet.